Well, good morning and good afternoon, everybody, and welcome to another very exciting Exploring by the Seat of Your Pants broadcast. So many of you are joining us for the very first time today, in which case, welcome to the show. We are all about bringing conservation, adventure, and science into classrooms around the world, and everything we do goes to our YouTube channel. So you can check out like 4,000 programs here. You can check out this one in 3 weeks, 3 years, whenever you're keen to tune in. Lots to explore and discover. And I'm really excited of all the days you could have joined us that you're here today, because today is really big for two big reasons. Number one, this is February. This is our entire month solely dedicated to showcasing the most amazing women in science and exploration on planet Earth. Every February for 11 years, we kick out all the dudes other than Joe and I as hosts, and we spend the whole month with like 50 amazing broadcasts. So if you want to learn about sharks or earthquakes or the James Webb Space Telescope, we have done programs this month on all of those and more, and we've got like 10 more to come. So much to explore and discover. And two, we are back with our friends at the World Wildlife Fund. So we do an epic series with the WWF for years now. You can check out all our broadcasts here. We've got some other cool ones coming up in the months to come. But today, specifically, we are going to talk about a very big topic, something that comes up in almost every broadcast we do, which is climate change, and specifically, how do cow burps help influence it? So to join in and talk about that, we've got Christa Anderson, the head of climate science at the World Wildlife Fund, which is one of the cooler job titles I think you can have in the world of conservation, science, nature, all that good stuff. So with her as our guide, I'm going to zip it, turn you over to her. I'm so excited for all your questions. And without further ado, Christa, welcome to the broadcast and take us away.
Hi, everybody. It's so great to be here. I'm so glad you were able to join in. As you heard, I'm Dr. Christa Anderson, and I'm an environmental scientist who works at the World Wildlife Fund. Mainly, I work on climate change, but environmental scientists work on all kinds of things. So I wanted to start out by telling you a few of the things that I've gotten to do as an environmental scientist, because I think it's a super cool job and one you might be interested in too. Here are some examples. For example, measuring trees. This is a picture of me. We need to know how fast trees grow in different places in order to protect them. And so one job I had long ago was working on a team in New Hampshire, measuring every tree in the forest. Maybe anybody here joining from the Northeast or near New Hampshire?
So many from Northeast.
All right. And for all of you here, I'm curious, can you think of what kind of favorite tree you might have? Maybe there's a tree in your yard at home or at a park that you go to or at your school that you really like. You don't even know what kind of tree it is, but you probably see a lot of trees every day. You might have a favorite one. They're all different kinds. Part of my job measuring trees also included measuring trees that are like this one, a little bit crooked. It's not too tricky a job. You take a tape measure and you measure around it, and you need to wear a bright orange vest, kind of like at a construction site, so the rest of your team can see where you are in the forest when you're measuring trees. You know, when a tree is really big like this one, I need another person. I can't just measure it by myself, but we need two people to get a tape measure around it. And doing that helps you know how much carbon is in a tree. Trees are made mostly of carbon. And you probably know that trees grow by taking carbon dioxide out of the atmosphere. They breathe in carbon dioxide and they breathe out oxygen. So they keep that carbon and they store it and they grow with that carbon. So it means we're taking some of the greenhouse gases that cause climate change out of the atmosphere when we go to grow trees. It's pretty cool. And it's neat because it's the opposite to humans. Whereas trees get rid of oxygen, humans breathe in oxygen. So that's another reason that we really like to be around trees. All right, another job I've had is using satellite information to check on forests. We can use satellites way above the earth to look at where forests are growing and where they're being cut down. And then, of course, we go visit them to make sure our data is accurate. This is a chance I had to work on forests in the Amazon and Peru. You can kind of tell you're in the Amazon because you see all those kind of roots behind me, and I'm wearing big boots because it's often very wet and muddy, checking on those forests and seeing where are we seeing forests grow and where they're being cut down. Another kind of role of an environmental scientist is observing wild animals out in the wild to understand how they live. This is a time I got to do that kind of work in Tanzania, that's in Africa, looking at how zebras live and what kinds of environments they need to be successful and be able to be protected. Okay, just one more example of the kind of cool things you could do as an environmental scientist. Here I'm in Tanzania, again on a different job, working with my friend in the background, Saruni, where we were collecting information on when people's cows or goats were eaten by wild animals like lions. We wanted to understand that so we could help people be able to protect, of course, their cows and goats from being eaten. And at that time, this is the first lion I ever got to see there in real life. I was really excited, and I was lucky to be in a car, so I wasn't too worried about it. I wanted to share with you those examples because I think it's super fun to be an environmental scientist, and it's just a great job. I've got to spend a lot of time outside, like you saw, and going on adventures. And most importantly, I get to help the planet every day. So I encourage you to think about that. Environmental science is a really fun area to study, and you might be interested in it already or interested in getting to know more about it. All right, now, since I was talking about how I was in this area of Tanzania collecting information about when cows get eaten by lions, that brings me back to cows. And that was our main topic for today. Why do cow burps matter for climate change? You know about climate change, right? It's about how our planet is getting warmer and the weather conditions on average are changing because greenhouse gases are emitted from the stuff that we do, and they cause climate change. It's a problem. But why do cow burps matter for climate change? Well, thanks to PBS Digital Studios with Curiosity Stream and the American Chemical Society, I want to turn it over to a quick video that'll let you know a little bit about cows and cow burps. Take it away, Jesse.
Sweet. I'm going to play this on behalf of Christa. And I just want to note, too, that I'm so glad you mentioned Tanzania so much. And this is one of the most amazing places on planet Earth. So cool to get to feature some really neat research there. But let's dive in with our video and get
in PBS Digital Studios. If you grew up in suburbia like me, you might not have ever considered the fact that cows are pretty gassy creatures. Just ask the German farmer who in 2014 had to deal with a slight exploding shed problem thanks to his dairy cattle's burps. Turns out the thing that exploded was methane, aka the natural gas you might use to cook your food. And Bessie over here can belch up something like 200 to 600 liters of the stuff every single day. Methane is a product of the crazy digestive system cows have with 4 stomachs. Stomach number 1 is called the rumen, and it's home to a microbe zoo. From protozoans to archaeans, you can find practically every major kind of life in there. Why? Cellulose, the carbohydrate that makes plants tough and fibrous, is technically impossible for the cow to digest on its own, which is why it needs the help of all those little microbe friends. Some of them take the cellulose and break it down into less complex molecules that the cows can then digest. The microbes release hydrogen gas and carbon dioxide as waste products. That hydrogen gas, if it were allowed to build up, could interfere with further digestion. So another group of microbes called methanogens take the hydrogen, react it with the carbon dioxide, and produce methane. The cow can't use the methane, so it just burps it out. Improperly ventilated barns aside, the real reason to be worried about cow burps is that the methane is a nasty greenhouse gas. Over a period of 100 years, 1 kilogram of methane could potentially warm the earth about 28 times as much as a kilogram of carbon dioxide. And cows, along with other livestock, emit many, many kilograms of methane from their burps. About this many in 2007. That's enough to make up about 7% of all greenhouse gases emitted by human activities. The planet is paying a high price for our burgers and shakes. So what can we do to save us from ourselves? Well, there are a couple of options. Either cut down the amount of methane the cows produce in the first place, or find a way to capture and use it. People are experimenting with adorable little backpacks to collect cows' gassy emissions, but it's probably more efficient to stop the burps in the first place. And scientists have tried pretty much everything with mixed results. One approach has been to vaccinate the cows against their own gut microbes, persuading their immune system to straight up murder those methanogens. Researchers have also supplemented cows' feed with essential oils like garlic, peppermint, and eucalyptus to aid their digestion. And because the amount of methane a cow produces seems to be inherited, some researchers are on the hunt for a breeding fix, breathalyzing cows to see who's got the least methane on their breath and sending those clean ones off to have babies. So there's no shortage of creative solutions once we actually put them into action. Until then, enjoy your gassy half pints and exploding barns. Curiosity.
All right.
Right.
Thanks so much, Jesse. So you heard it there. Cows are so interesting. Their stomachs are really different than human stomachs. And so they burp out all this methane when they're digesting their food. And methane is a really strong greenhouse gas. You heard from the video that it's about 7% of our greenhouse gases that are produced. Now I want to show you a pie chart. So that means we're going to make a big circle that's going to fill up to 100% of all the greenhouse gas emissions that humans produce. So you heard already it was 7% from cows. You see the cows in this picture here, and they're part of this bigger wedge of the pie. It's kind of a big pie slice. That's 24%. These are our human emissions from agriculture, forest, and other land use. So in addition to the cow burps, this is also our greenhouse gas emissions from cutting down trees and forests. Those trees, that carbon gets released into the air as carbon dioxide. And it's also from all the food we eat, not just cows, but also we produce a lot of emissions when we do farming, for the fertilizers we use, for the kinds of ways that we till fields. And that stuff is, of course, really important. We're still going to keep eating. We're still going to keep producing those emissions. But there are some solution pathways that we're also working on. Like you heard about in the case of the cows, we're experimenting with feeding cows different kinds of food that makes them burp less. So that's that piece of the pie wedge. Let's see what the others are for where we produce greenhouse gases that cause climate change. The next one is a bit of a small one. It's just 6%. You see, that's a very small pie slice. It's from buildings. This is not all the energy in the buildings you're in, but it's mainly when you use heat, like a fire, or maybe you have a stove at home that you cook on that uses gas. That's what these emissions are. So energy you produce at your home from cooking or from heating your home right there yourself. Okay, the next wedge is a little bit bigger, and that one you might have heard about before, transportation. So transportation accounts for about 14%. That's kind of a nice, good slice of the pie for our greenhouse gas emissions. So that's the gas you burn when you drive your car, creates greenhouse gas emissions. Same with airplanes when they fly. All kinds of transportation causes greenhouse gas emissions from burning the gasoline or those other fossil fuels. So what are the solutions here? You might be familiar already. New cars can be built that are electric vehicles. So you plug them in to charge them instead of using gas. You might have been in an electric car or seen one somewhere else. And when you plug them in to get energy, that energy can be produced from renewable sources like solar or wind that doesn't cause greenhouse gas emissions. So those are some of our solutions for transportation. Of course, another one is sometimes if you're in a place where you can do it, riding your bike to get to school or work. I live actually in St. Paul, Minnesota. It's a pretty cold state, and I know some of you guys are also in cold winter states, so you don't always want to ride your bike to school or work in the winter, and we don't either. But come summertime, we'll be excited to get on our bikes again. All right, the next wedge of the pie, what's it going to be? Here we are. It's a big one. 21% of our emissions are from industry. What does that mean? You could think of here big factories that are producing things that are ingredients for other things we use. When we make cement, for example, in factories, it causes a lot of greenhouse gas emissions. And other things that we make in factories that require a lot of heat to make them or to dry them, that causes a lot of emissions as well. What are we doing here for solutions? Well, again, we need to transition these factories to renewable energy sources. We say we electrify them, and then they can run off of things like solar and wind and hydropower. Okay, we're getting towards looking at 100% of the pie and knowing what all our sources are. There are just two more wedges, and I'm going to show them to you both at once. It's a 25% blue wedge and a 10% green wedge. Some of you math folks out there, 25 plus 10 makes 35%. That's our final piece of the pie, and it's from energy. It's the biggest part. So this is all of our electricity and heat production and other energy, which is a subpart of that. You can think of all the lights that you have at your school or your home, all the things you plug in to get power. Maybe you have games or clocks or other things that you need to run on power. Our computer, the computer I'm using right now is using energy. All those things that need electricity are a big source of our greenhouse gases because mainly we get that energy still from fossil fuels. But what are the solutions here? Well, you probably know already some of them. We can use solar power, energy from the sun, to replace some of the greenhouse, some of the fossil fuels. We can also use wind power, and we can also use hydropower, power from water, in order to avoid those greenhouse gas emissions and improve our emissions inventory, we say. So this is all information from the US EPA, the Environmental Protection Agency, and the IPCC, that's the Intergovernmental Panel on Climate Change. And those are the group of scientists, environmental scientists, and climate scientists like myself who study these kind of things, who figured out how much of all of our greenhouse gases are in each of these wedges, and what are the things we can do to solve this problem and reduce climate change. So as you heard, cows are a big deal in that wedge, and so are all those other things. What can you do about this at home? I have a few suggestions because I know that you're probably interested in climate change too. One thing you can do to help is to save energy. If you're not using a light or you're not using something that you've got plugged in, you can turn it off. Another thing you can do is plant a tree. Like I said, trees are mainly built of carbon. And when they grow with that carbon, they're taking carbon dioxide, an important greenhouse gas, out of the atmosphere. That means there's less climate change happening. Finally, and most importantly, you could tell other people about climate change, including telling them about cow burps, because it's really interesting when you get into the details of all the different things that can cause climate change and that contribute to our greenhouse gas emissions. All right, thank you guys so much. That's where I want to pause and turn it back to Jesse.
Amazing. Well, Christa, thank you so much for the deep dive. We've got tons of time for Q&A. We got a whole bunch of live classes, tons of folks on YouTube. So if you're on YouTube and you want to start sharing your questions in the chat, whether you're on the Wild Classroom or our channel, please do. I'll be able to see all of those live groups. I'm coming to you all in just a second. So our STEAM group in Idaho, Miss Vega, Madam Sylvie's class, Reading Fleming, we're coming to y'all. So please do put on those thinking caps and we'll dive in with some questions. Christa, our first one from one of the chats is, how long have you been doing this and what prompted you to get your start? Was there any specific thing that made you go, man, I really want to work in climate, or what's the deal?
Oh, that's a great question. I've been working in climate my whole career, more than 20 years, a really, really long time. And what got me interested was growing up here in the state of Minnesota. I got to work in the outdoors as a canoe guide. That meant taking younger kids when I was in college on canoe trips in a really amazing wilderness forest area we have here called the Boundary Waters. I loved that forest and I loved spending time outside. And I got to know that climate change was one of the problems that we had that was impacting that forest area. I thought, how could I work on the problem of climate change and continue to get to spend time outside in these places I love and love exploring? And that's how I came to the work that I do today, finding out ways to keep on doing those things that I really enjoy while also tackling this problem of climate change that I care a lot about.
It's so fascinating getting to work with so many different experts in biology and conservation, climate science, and pretty much universally, it's some big outdoor experience they had when they were younger. Like, I can't stress enough, I grew up in Toronto, which is a big city, 3 million people, but like every chance I got, I went to parks, and sometimes that was provincial, national parks, but even just like your local park and seeing the wildlife that's there really has a profound influence. So I can't encourage you enough. If you're a student, get outdoors, go explore, you'll fall in love with it, and maybe you'll end up with a cool career like Christa's. Very, very cool. All right, our Crystal STEAM crew, come on in, unmute your mic, and you can be our first on camera for a question. Hey guys, great classroom. Man, look at that tree in the back. Oh,
Yeah.
so cool. You're in.
Come on.
That's a beautiful tree. I wonder if that's somebody's favorite tree. I love that.
Seriously. Hey.
Go ahead.
Hi. So do you teach other schools?
Oh, do you teach other schools? Christa, do you do any outreach with other classes or universities or anywhere? Yep.
Well, I do sometimes I get to go, I have kids myself and they're in second grade and pre-K. Do we have any second graders or kindergartners here?
Not on camera, but we do have them on YouTube. Yeah.
Sometimes I get to go to their school in real life and do teaching at their school, not super often. The other place I teach in a college. So those are students who have finished high school, they're done with grade 12, and they are in college. And I teach a climate change class for college students, which I think is super fun because I get to share more and more about climate change with those students. So those are the main times that I get to do teaching, but I love talking to students. So I'm so grateful I get to be here today too.
We're so grateful to have you. I think we've got like 20 US states and like 5 provinces today. It's like a crazy large audience. So very excited to have all you classes. Thanks, guys, for the first query. Ms. Vega, we're going to head to Chicago. Come on in, unmute your mic, and you can take us away with the second one. Hey, guys, welcome in. Come on up.
Hello.
Hey.
So our students have 3 questions. The first question I have is, what is the largest contributor to human-caused global warming?
Sweet.
For sure, for human-caused global warming, it's all of our energy emissions. So burning fossil fuels for all of the energy that we need for warming our homes, for giving power to our homes and businesses. All of that is the biggest share, that about 35%. So that's the biggest one and the one to think about. And of course, energy comes into all aspects of your life. If you think of the things you do in a day, it's hard to think of a time when you're not using energy. For me, I get up in the morning and I turn on my light. And then I go to my computer and I turn it on. And then I warm up my breakfast in the microwave. We use a lot of energy and we need it. And the way to solve that problem is to use cleaner sources of energy, solar power and wind power and hydropower.
Well, and I want to stress, and this wasn't our big focus today, but like the amount of wind and solar energy that's being input in the world. Like when I was the age of our students today, it was such a small percentage of the global power supply, and it's so much bigger now. It's the cheapest source of power in the world. So it's like this golden age, really, really exciting time to be interested in the engineering of that, in the input of that. Ontario, where I grew up, is a lot of hydro and nuclear power, which are green energy sources. So really, really exciting times. And I'm glad we got that question. We will come back to Ms. Vega's class for a second and third, I promise. I'm going to head to Quebec for Madam Sylvie's class. If you guys want to unmute your mic, flick on that camera, we can bring you on. Come on in. Hey.
Hi, my name is Jackson, and my question is there another animal with methane?
Oh,
that's such a good question. I was hoping someone would ask that. So the biggest source of the methane burps is cows because of their special stomachs. They're called ruminants because they chew their grass and they have 4 separate stomachs that do that. There are other animals that are ruminants, that are livestock, but not very many. So the biggest source of methane burps is cows. What about humans though? Do humans burp methane? Not really. We burp other gases when we burp, and we don't burp nearly as much as cows because they have that special separate stomach system. You burp, I don't know how often you burp, once a week, once a day, not too often. But it's not a greenhouse gas when you burp either. Cows, it's a greenhouse gas and they're burping all the time. It's part of how they digest.
Yep. Okay, man, such a great first round of questions. You guys are awesome. Keep them coming. Keep your thinking caps on. Reading Fleming, we will come to you if you want to share in the chat. I'm going to head to YouTube for a couple, and then we'll go back to all our live classes. So Miss Lattis, Peel Virtual Elementary School, welcome in, guys. One of the big questions from Angela is, can we reverse climate change if we all take small actions? Is there a way that we could actually undo some of the damage that's been done? It's a big question.
For sure we can. We've put all these greenhouse gases in the atmosphere, but we do have ways to take them out of the atmosphere, right? And some of those are, for example, by growing trees, because trees trap carbon. They grow by storing carbon, and that takes carbon dioxide, a greenhouse gas, out of the atmosphere. We also can undo it by storing more carbon in soil, in dirt. When we use regenerative agriculture, when we use good farming practices, we store more carbon in the soil, and that helps take greenhouse gases out of the atmosphere. A third way we're doing it actually is with technology. We've developed new ways to pull greenhouse gases out of the atmosphere and then store that greenhouse gas in liquid and solid forms deep underground, in holes underground. That's pretty new technology. So we're still getting good at it and learning how to do it better. But those are the ways that we take greenhouse gases out of the atmosphere after they've already been entered. And that's how we can reduce climate change after we've already emitted those gases.
I
The other
love-
part, like I said, is emitting less gases as we go along.
We're going to come back to that theme a lot, but I want to stress for our kids, I'm so glad we got that question in particular. I can't encourage this book enough for our grade 8 and above students. So Drawdown is spectacular. There's an amazing website for it. So WWF has a lot of great resources as well. Drawdown.org. So many ways on how we can reduce and sort of undo some of the climate change impacts we've had. One of the best resources we've ever come across here at Exploring by the Seat of Your Pants. So thank you very, very much for that. Redding Fleming, I know you have a question, but you need to share it in the chat because your devices aren't on. So put it there and I'll pass it along to Christa, I promise. We've got a cool one of what's the biggest cause of climate change that's easily avoidable? Is there like a go-to example of something that's really easy to mitigate?
Well, one that I could talk about is methane. So you heard now about the methane from the cow burps. We also have methane emissions that are called fugitive emissions. So it's basically hidden sources of methane just leaking from pipes that we have for other purposes. And methane, when it leaks out into the atmosphere, you don't see it. It's invisible. And so we don't always know where those leaks are in different pipelines for different factories and production and energy. But when we pay attention to it, where those leaks are, we can easily stop those leaks, just like you stop like a water leak in a pipe. And then you're not emitting that methane, and then you don't have those greenhouse gas emissions. And since methane is such a powerful greenhouse gas, that's a super easy one. What's really cool in this space is that we have newish satellites just over the last few years, that these are satellites that can actually see this invisible methane and identify where these leaks are. So we're getting better at stopping these leaks so that this is an easy win for the climate. Let's not have those leaks of methane that we don't need.
Honestly, this was not a thing when I was a kid. It's been so interesting in the last few years seeing this exact thing where it's like, oh, we can shut down something that's producing as many emissions as like Belgium, just by going out and fixing things that are really, really easy to mitigate. So I'm glad, guys, great questions. Redding Fleming, you're in now. Cool. Unmute your mic. Come on and join us and take us away. Hi, Miss Coster's class.
Hi there.
Hi.
So we have a question. Go ahead, Lila.
How do scientists measure the methane in cow burps?
Ooh.
That's such a great question. Okay, so part of it we do by actually putting machines that measure gases by their mouths and figuring out what they're burping out. Another way we do it, you saw in the video the picture of the cow with kind of a backpack on. So that's a way where they actually put that backpack and connect it directly to the cow's stomach. So instead of the methane coming out the mouth, they just trap it there and measure it coming straight from the stomach so they can measure what would have been burped out. Isn't that amazing? And then they don't want to do that for every cow, of course. That would be kind of crazy. So then they build models to estimate, if one cow has 7 and one cow has 8 and one cow has 10, then they can make an estimate and model what we think are the average emissions from cow burps.
Yeah. One thing that I want to stress, and you talked about this a bit in your talk, but one of the easiest ways that as students, as people, you can help make an impact on climate change is to eat less beef. So like I married a vegetarian, so I eat a lot less meat than I used to. And that's going to be bigger than anything I'm going to do with changing light bulbs, anything I'm going to do with driving a little bit less, like consuming less meat. It's one of the easiest ways. A lot of other protein sources, not to say you need to cut it out entirely, but it is a really big impactor. And I'm so glad we keep talking about our methane burps in this. Crystal Steam Crew, we're coming to you guys. We're going to do a whole other round of questions as we're whipping through these because Christa is super fast. So come on in, take us away.
Yay! Okay, Miss Donna, come. Tell them your name.
Oh, I am Miss Ghana, and I have a question. How many countries have you been?
Ooh.
Oh, that's a good question. I don't know if I've counted.
I like your
Probably-
website. I put in the chat for everyone the website of you on WWF, and like the list of places you've worked is out, like it's the largest of anyone I've seen in ages. Do you have a rough idea? You've been to how many continents? How about that?
I would guess, 4 continents. I
Okay.
would guess about 20 countries. I've been lucky to work a lot in Africa because there's so many cool environmental science challenges there, and also in South America. So I guess about 20 countries.
That's pretty special for an amount of work. Most scientists, I will say, to be a doctor, you do need to be in school for a long time. So, you finish grade 12, you're going to an undergraduate for 4 more years. You're a doctor, you're going for 4 or 5 more years. And that sounds really daunting. But like at the end of that, you're really young and you get to work with the coolest people in the world doing things that you love and get to nerd out over. And quite often you get to travel internationally to do those things. So it's not for everyone, but if it is for you, there's a lot of really cool perks of being a doctor in climate or any other kind of science. So thanks, guys. All right, Ms. Vega, you're sharing in the chat. I can come to you live if you're still here, and you can flick on your camera if you are still there. But while we're waiting for that, we'll go back to Madame Sylvie's group. Come on in Quebec and take us away, guys. Hey.
Hi, my name is Edith.
Start again. Yeah.
Hi, my name is Edith. Is fire bad for the environment? And if it's percent?
Ooh.
Oh, that's such a good question, Edith. Thank you for that. I did have that little picture of fire in the pie chart. Maybe you saw that. So it's true that fire is one of the ways that we cause greenhouse gas emissions, because our fires, usually they burn wood, and wood and trees are mostly made of carbon. And when they burn, they produce carbon dioxide, which is a greenhouse gas. So that does cause climate change. Now, that's the fires that we burn maybe to warm our homes, like I do here in Minnesota, or maybe you have a bonfire when you go camping. But also there are big forest fires that can start from lightning. Those cause the most of the greenhouse gas emissions. We don't have a lot of greenhouse gas emissions from fires that we're burning just to warm our houses or from our bonfires. If I had to guess, I think that's probably like 1 or 2%. It's a pretty small source. One of the main things that we're doing to try to have less carbon dioxide emissions from maybe people's fireplaces at home is that many states in the United States and in other countries are encouraging folks who have fireplaces where they burn wood to burn cleaner fuel, or to think about changing their fireplaces to gas, or to have cleaner stoves that can burn up all of the wood completely, so there's less black carbon being released. That's the little particles that sometimes fly out of your fire, and they're bigger greenhouse gas causers. So there are solutions there too. It doesn't mean you can't have a fire.
Yep. I want to stress for our classes that might have been to it, like an outdoor fireplace. It's a big part of me growing up in Canada. Like you smell it. You smell it for days because it's literally like chunks of the wood that are in your clothing, in your hair. That soot is getting out there, as opposed to like a clean fuel like you might have in a gas stove or any other number of things that are just much more efficient, effective ways of cooking. And you'll see this in other countries. Krista's been to a lot of places where it's very common to cook with a stove like that inside a house, where it's really sooty and dirty. It impacts your lungs. It impacts a whole bunch of things beyond just climate change. So really, really important and a really easy thing that a lot of folks can do. Great question, guys. All right. Ms. Vega's class had to go. Before they did, they have a cool question. If methane is one of the big causes of global warming and cows burp methane, how long have they been one of those big slices of the pie?
Oh, that is a very good question. Well, cows are a domestic animal, right? It means they mainly live with people. Some cows do get wild and they can survive on their own, but most of the cows in the world are around because people wanted to have cows around on their farms or on their ranches. So as we came to have more people, we've come to have more cows. And as we eat more beef, we have more cows too. So it means that a long time ago, let's say even 200 years ago, even 100 years ago, we just had fewer people and we didn't eat as much beef. So cows were not such a big deal. Their methane production was the same. We just didn't have as many cows. Now, fast forward to today, we have a lot of cows because we have a lot of people to feed, and a lot of people are eating a lot more beef, like you heard from Jesse. So it's really in the last, let's say longer than your lifetimes, but maybe 30 years or 40 years, that cows have become so numerous, so many cows all over, that it creates a lot of methane emissions that's contributing significantly to climate change.
Yeah. Well, and I'm glad we keep harping on the methane too, because things like chicken, it's still meat, but it produces way fewer carbon emissions than something like a cow does. Cows are sort of like the gold standard, highest, most emission thing you could possibly imagine ever. So even if you switch some of your beef to chicken or to plant-based products, certainly, you'll have a really, really big impact on climate. It's one of the easiest things all of us can do. Again, one fewer portion a week will make a really big difference for the world. So great question, guys. All right. Reading Fleming, we're going to come to you, and then time flies and you're having fun. So we are nearing the end of the broadcast. I'm going to stress we have a whole bunch of amazing programs with WWF coming up. You can watch this one, share with your family and friends here as well. If you have extra questions, you can email them to us at exploringbythecyourpants, and we'll pass them along to Christa. But let's head to Flemington. Come on in, guys, and take us away. Hey.
What inspired
Hi. I have a question. What inspired you?
Oh, that's such a good question. What inspired me? You know what? I had some great teachers when I was a kid who always encouraged me to ask questions. Hey, is there something that you don't understand or you don't know about that you want to learn? Why do we think that cows contribute to climate change? Or why am I so cold in the winter and yet so hot in the summer? Why do the seasons change? I just had lots of questions like that. And I had some really few great teachers who encouraged me to keep asking questions and look for answers. And that's really like the core thing about being a scientist. You just keep asking questions and then finding ways to search for answers. So that's why I've been loving your questions here today.
Yeah.
I do want to turn to one last question you guys didn't ask. What about cow farts? Okay, sorry teachers, but that does matter. Mainly cows burp methane. They do also fart some methane, but more burping than farting. So farting does cause greenhouse gas emissions in humans and in livestock. But by far, for cows, burping is a bigger factor. All right.
More burping than farting will be our next byline the next time we do this program. Thank you very much for that, my day. And I'm so glad you mentioned the curiosity element, because I think when I was a student, the age of our classes today, I assumed that people that were top scientists were like the smartest of all time, all the time, starting when they were really young. And like the one unifying factor is not that between astronauts, cave divers, people like Dr. Anderson. Like, it's curiosity. It's just being really interested in the world around you, recognizing that you don't have all the answers and seeking out those answers from people who know better than you. Most people are really excited to share their knowledge. And certainly if you go get some books, it can go a long way to helping you be more informed. So just by showing up today, you guys are doing a great job. And we really, really appreciate your attention and everything. Christa, before we wrap up and say goodbye, is there any final message you want to leave us with before you bring in the kids for a big farewell?
You guys, remember, I'm so excited that you already know so much about climate change, and you can contribute to limiting and stopping climate change every day. Think about turning off your lights when you don't need them. Think about recycling. Think about planting trees, and tell other people about climate change. Thanks so much for being here.
No better message than that. We're going to bring in all our classes to say a big thank you and farewell. So our Crystal Steam crew, Madam Sylvie, Reading Fleming, thank you so much, everyone. Unmute your mics. Join me. If you're at home on YouTube, you can scream and yell too. Goodbye for now, everyone. We'll see you.